All right, today we're talking about ellipses. Okay, how is an ellipse defined? It's the set of all points in a plane or two-dimensional surface such that the sum of the distances from two given points, called the foci, and these are our foci here, is constant. Meaning if I picked a point here and I drew a line to both foci, pretend those are nice and straight, and we were to add them together. So I'm just going to make up some numbers here. Let's say this is 8 and 4, so they add up to 12. Now, if I drew one over here, a point here, maybe this is 10 and 2. So the sum of those two distances would always be 12 in this particular case. So that's what it means. The sum of the two distances, if you measured it straight back to those foci, is the same. In fact, people used to show this, if you take two pins and you get a piece of string that's a little bit longer than those two pins over here, and you kind of force the string to tension and wiggle your finger around, you will draw in your ellipse. Okay, so let's go ahead and label in a bunch of important stuff here. So here comes a lot of data. All right, so these are our foci, as we talked about before. Okay, so our two foci here. Now, exactly halfway between them is the center of our ellipse. And our center will once again be using h and k in our formula. Okay, so if we talk about some of these distances, we have a smaller axis, unlike a circle, right? We have one that's a little bit longer than the other. So the longer one we call the major axis, and the minor axis is the smaller one. Okay, and these can switch if it's more of a vertical, ellipse. Maybe the major is vertical, minor is horizontal. Okay, we'll cover both cases. So let's call the distance along the minor axis A. We're going to call the distance from the center to the focus B. Okay, and that can be in either direction. That's a length of B. And then we're going to call the distance from here to all the way to the edge, okay, is actually C, which does end up equaling the same as this length here. Okay, and that makes sense because if you think about if these distances are always the same, imagine when they're here, the distance from both foci actually ends up being kind of subtracted there. But it ends up being the same as those two together. So anyway, we'll move on from this. But you might notice that this forms a right triangle. Okay, so we're going to say that this is also true, and we can use this to help find missing information sometimes, that a squared plus b squared equals c squared. Even though you can also think of this length as being c, but it's nice to have it there in our right triangle. Okay, so the minor axis is twice the length of A. The major axis is twice the length of C. So here are some of our formulas. Okay, for one like this, our horizontal ellipse, here is our standard form, where h and k are the coordinates of our center. Okay, c squared, so whatever this length is, here or here, right? That value squared goes underneath x. A, half the length of the minor axis, squared goes underneath y, which is the minor axis here. Center is at hk, the major axis is twice c, because you have two values of c, and the minor axis is two values of a. Okay, to find our foci, if you want to find their coordinates, which we usually do, is we start at the center, and remember that this distance is b, right, to get to both of them. So my horizontal distance here, which is h, right, our x coordinate is going to change. We're going to go forward b, so we would add b to get to one of them, and then we're going to go backwards b, so subtract b to find the other. So h plus b and h minus b, keeping the y coordinate the same because we're not moving up or down here, is how we find our foci. Okay. Now, when it's a vertical ellipse, the larger axis will be underneath y. Note here that the larger or major axis value c is underneath x. This will always be the larger of the two denominators. Okay, and when it's vertical, the larger of the two denominators goes underneath y. So a major vertical axis, so it's a vertical ellipse. Okay, so our center here is still at HK, the major axis 2C, minor axis 2A. This time, though, to get to the foci, we need to be moving up and down from the center B units. So H would stay the same, but we need to do K plus and minus B. Go up and down B to find where our two foci would be. So that's what that's describing. Okay, let's try some examples. Okay, identify the orientation, coordinates of the center and foci, and the length of the major and minor axes. Okay, well, let's start with the easy one. Let's start with the orientation. And we can figure this out by looking at which denominator is larger. The larger denominator is with x. That means it's more horizontal. It goes more in the x direction. So we know right away, larger denominators with x, this is horizontal. Okay, next we can identify the center. It's probably the next easiest thing to find. -3, +1. Remember h and k are kind of the opposite signs here. So there is our center. Now the foci is usually the tougher one, so we'll come back to that. Let's do the major and minor axes. So the major axis, remember that this value, the larger one, is c squared, which means c is actually 13 if you were to square root that. So remember that c is the length of half of the major axis. So we actually need to double that value. 26 is the length of our major axis. So the smaller one, smaller denominator, is a squared, right? A squared. So a must be 5. And likewise, that's the length of just half of the minor axes. So we need to double it, which gives us 10. So the minor axis is 10. Okay, so last we need to find the coordinates of the foci. And this is more difficult because we need to find the value of b, and we don't know b yet. So how do I find b? You guessed it, Pythagorean theorem. We know a squared plus b squared equals c squared. And we can use that to find our missing value of b. Well, we already know what a squared is. It's 25. We already know what c squared is. It's 169. So if we subtract 25 over, you get 144. And if you square root that, keeping only the positive case here, because we're talking about lengths, b is 12. So to find our foci, in this case in the horizontal one, we need to go left and right 12 from -3. So -3 plus or minus 12, comma 1. And we can go ahead and actually calculate these. -3 plus 12 is 9. So 9, 1. -3 minus 12 is -15, 1. So those are the coordinates of our two foci. We've got our major axis and minor axes, the center, and orientation. All right, let's try the second one here. Again, the first thing I notice is the larger denominator is underneath y. That means it goes more in the vertical direction. So this is a vertical ellipse. Okay, let's also go ahead and find our center, the next easiest part to find. Now notice if there's nothing with x, that's because h is 0. And here our k value is -4. So 0, -4 is the center of our ellipse. To find our major and minor axes, remember the larger one is what c squared, think like hypotenuse has to be the biggest, right? So c here is 6. And remember the major axes, we need to double that because c is only half the major axis. So the major axis has a length of 12. Remember the smaller one is the value of a squared, which means a is 4. And since that's only half my minor axis, we know the minor axis is 8, 4 times 2. Lastly, to find our foci in the more vertical direction, this time it's the y coordinate. We need to go up and down b. So h stays the same, and it's going to be our k value plus or minus b. We just need to solve for b. So again, we go back to Pythagorean theorem. A squared plus b squared equals c squared. A squared is 16, b squareds are unknown, c squared is 36. Subtracting 16, we get b squared equals 20. And by square rooting both sides and simplifying, you get b is 2 times the square root of 5. Now here you could write these individually, but we can't actually calculate them without going to a decimal, because it's not a nice integer this time. But that's okay. They're not always going to be nice integer values. -4 plus 2 times the square root of 5 and -4 minus 2 times the square root of 5. You could calculate those decimals out and find exactly where they are on your graph. Okay, given each in general form, write the equation of the ellipse in standard form. So this is going to require us to do completing the square for both x and y. So the first thing we do is we always move our constant to the other side. And then we're going to go ahead and pair up our terms with x. So I've got 4x squared minus 40x. Okay, and then we're going to leave some room. We'll go ahead and pair up our terms with y. Positive 25y squared plus 100y. Leave a little bit of room, equals 200. All right, to complete the square for each of these, we are going to need to factor out a from each pair, or the value in front of the squared term. In this case, 4 from x. So we're going to factor out 4 from these two terms. That leaves me with x squared minus 10x. And that's where we're going to put our plus blank inside of our parentheses, just like with circles. Next, we're going to have our 25 factored out of both terms for y. That leaves me with y squared plus 4y. Okay, and again, we'll set up a plus blank to complete the square for y. Now, just so we don't forget, we're going to have 200 plus blank plus another blank. Our two new values we need to also make sure we add to the right, keep our equation balanced. So let's complete the square. Remember, it's half of the middle term, half of b squared. So half of that is -5. -5 squared is 25. Complete the square for y. Half of b would be +2. Squaring it, we get 4. Half of 4 squared is 4. Okay, now remember, the value we're really adding to this side is not just 25 and 4 this time. It's 4 times 25 and 25 times 4. So really, that's a value of 100 for both of them. So we really need to add a total of 200 to the right-hand side. Now on the right, we're going to go ahead and factor our perfect squares here. This becomes x minus 5, quantity squared. Remember, it factors is half of b. This one, I'm going to get plus 25. Half of 4 is +2. So y plus 2, quantity squared, is the perfect square we created. And adding all that together, we get 400. Okay, now remember, for standard form for an ellipse, we need it to set equal to 1. And the way we do that is by dividing everything by the constant over here. So we're going to divide both of these, and they should reduce for us. Okay, so now let's go ahead and reduce these. 4 and 400, if I divide by 4, gets me a 1 up top and 100 on bottom. Okay, next when we divide by 25, top and bottom there, 25 goes into both. That is 16 quarters and $4. Equals, and 400 divided by 400 is 1. There it is in standard form. We know lots of things about it now, like its center is at 5, -2. We know it's a horizontal ellipse because it has the larger denominator under x. And you could figure out, of course, where the foci are and major and minor axes like we did before. Okay, here's D. Try this example out. See if you can go through these same steps of completing the square and then eventually dividing by your new constant and simplifying, and see if you can get all the way to the end here. So pause the video now, try this one out. All right, hopefully you got to x plus 3 squared over 9 plus y plus 2 squared over 16 equals 1. So if you're not sure, pause the video. You can look through the steps here, figure out if you made a mistake. Okay, two more questions. Write the ellipse described in standard form. Okay, so that's the form we just converted those previous two into. So its major axis is horizontal. So I already know I can kind of start with a template here. Then we have our x minus h squared, and we know c, the larger one, will be underneath x if it's horizontal. Y minus k squared over a squared, and it should equal 1. So there's our template. I know it's horizontal. So we can plug in our center for h and k. If h is 3, it should look like x minus 3 squared. If k is 4, it should look like y minus 4 squared equals 1. We just need to figure out the values of a and c. Well, if the major axes, which is equal to 2c, right? 2c equals 12, then c has to be 6. And now that I know the value of c, we can square it to put underneath, right? C squared is 36, and that's what would go underneath x, our larger axis. The minor axis, which is 2a, it says is 4 units long. Therefore, we know the value of a is 2, and a squared happens to also be 4. So there you go, figuring out our information there. From what they've described, we've come up with that exact ellipse. Here's a more difficult version of a similar question. So notice this time it doesn't tell me if it's horizontal or vertical. We're going to have to figure that out. They did give me the center, which gives me an h and k to plug in. So x minus 9 squared over something. We're going to have y plus 5 quantity squared over something, and I know it's going to equal 1. I don't know which one has the larger denominator, and I don't know my values yet. Well, let's see what we can figure out. So my center is at 9, negative 5. So I'm just going to pretend we're in the coordinate plane here. This is 9, negative 5. So I note that when I go to my focus, remember foci are always on the major axes, that my y-coordinate stays the same, meaning I'm not moving up or down. So that means if my foci is at 5, negative 5, then my major axis must be horizontal. We know it's horizontal, and we can actually measure the distance here to figure out the value of b if we need it. Right? So from the focus to the center, it looks like the difference between these two is 4 units. So I now have an idea that b equals 4. Okay, well, if I'm going from my focus to all the way to the vertex, so if I go all the way further out, that's just a point on the curve, right, of my ellipse, this horizontal ellipse here. It says that one of them is at 14, negative 5. So from my center all the way to my vertex, it looks like we've gone out 5 total units. And remember that that length also represented c. So since that distance from the center to the vertex is 5 units, we know c is 5. And because I'm pretty sure now that it is horizontal, c squared, right, 5 squared, or 25, would go underneath. Okay, well, how do I find a squared, my only missing value? Well, if I figured out b, the distance from the center to the focus, and c, the distance from my center all the way to the edge, then we can figure out a with Pythagorean theorem. A squared plus b squared equals c squared. So we don't know a. B squared would be 16 if b is 4. C squared we know is 25. And let's find a. Subtract 16 over. We get a squared equals 9, which means a is 3. In fact, I didn't really even have to go this far because I just need a squared in my formula. So a squared is 9. And there we go. There's the equation of the described ellipse. All right, so for these next two, go ahead and put them in the standard form here that we're going to need. Identify the center, the locations of the foci, the length of the major and minor axes, and then sketch the graph. So see if you can find all of the key parts to both of these. When you unpause the video, I will show you once I have the final forms how to graph them very quickly. All right, so here's all the painstaking work to put them in their standard forms, calculate all their important parts. I did go ahead and actually calculate 0 plus and minus 2 root 5 and round it to 1 decimal place because that's about as accurate as will be by hand. Same thing over here, our -1 plus or minus the square root of 21, and I rounded each of those off so we can kind of graph in our foci. So the first thing I want to start off with is the center. So our center here is at 0, 0. Okay. Then we know this is horizontal. So if the total major axis is 12, that means from the center I only want to go 6 left and right to get a total distance of 12, right? So we really just want to go left and right kind of C units, 6 units. That'll give us a total of 12. And if my minor axis has a total of 8, we just want to go up or down 4. Up and down 4, which is our A value. So if we kind of give our best sketch of some nice curves coming between these points, this is better than I expected. Don't worry, I'll mess it up. We should get a rough sketch. Yeah, I missed. Rough sketch of what this ellipse should look like. And now we can, of course, try to graph in our foci as well. Maybe at positive 0 and 4.5-ish. See, these are pretty far out here. And about -4.5 is 0 would be our foci. Okay, for our second graph, our center was at 5, -1. It's right here. And this one is more vertical, so my major axis is going up and down. So if the total is 10, I only want to go up or down 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, there's my major axis. My minor axis is a total of 4, so I only want to go left and right 2. Give me a total of 4. And so here's my rough sketch of what this ellipse should look like. I should do a better job rounding at the ends here, but you'll have to forgive me. Okay, now remember our foci are always on the major axis here. So 5 is the x-coordinate. We are at -5.6, really close out here. And 5 at positive 3.6, so somewhere way out here. So this is a much more elongated ellipse, and you can see the foci get closer and closer to the edges as they get more and more elongated. Okay, that's it. We'll have more examples in class. See you then.